This is the Chem 1 lecture over graphing.
The next thing we're going to talk about is graphing, and I realize most of you guys have made graphs before, so some of these rules might be familiar to you guys. Things like if we give you graph, usually we won't make you use graph paper, we'll just give you a little picture of a graph like you have in your notes. You need to at least fill up half that graph paper. You need to utilize the space. If we give you a graph that's half the page, don't give me a graph that's 1 inch in size, teeny tiny. So you do need to think about what those tick marks need to be, what the value needs to be. So an easy way to do that is to count how many you have and figure out what they need to go by. Divide by the range of your data that you're going to graph. Be sure you label your axes. So X and Y axes need to have whatever it is, so like mass, but also units. So is it mass in pounds or mass in milligrams? You do need to have that. Typically that's given in parentheses. You do need to have a descriptive title. The title does need to describe whatever data you're graphing, whether that means it's distance versus time, or if you want to be specific and talk about what that slope is. Well, if you're graphing distance and time, your slope is actually your speed. And you also need to have a line of best fit. So that's either going to be a straight line or a curve. In science classes, you're never going to play connect the dots between your data points, but you're always going to see the trend of the data and draw either a straight line or a curve through as many points as possible. And that way, again, when doing an experiment, you can kind of ignore those outlier data points that we may get. So in class, we went through and everyone collected some data points. So I grabbed some data from the website. So I've got 8 cups here, and I'm looking at the table over here. So I've got my 8 cups. I've got a volume of zinc, and I have a mass of zinc. So we're looking at density here because we have mass and volume. So important terms, so independent and dependent variable, and you've got these guys on your notes also. Those are important vocabulary terms for you to know, so graphing terms here. Independent variable is the one that's controlled. That's the one that the scientist changes, and it always goes on the x-axis, while the dependent variable is the one that changes. So it's usually the one that they're measuring as the experiment happens, and that always goes on the y-axis. So be mindful of those vocabulary terms. So what I did was I counted the number of tick marks I had on the graph, and I noticed that the x-axis, so we needed to put volume on the x-axis, and that the points went from 2 to 20. So I went through, and I think there's 22 tick marks here, so we could have used one for each of them. I did want to condense my graph a little bit, but I still used over half of it. And then same thing on the y-axis. I noticed my data points went pretty much from 0 to 100. So I made every other tick mark worth 10, or them worth 5. So what you could do is take the number of tick marks and divide it by your values, and we got about 5 per tick mark. So then I went through and I numbered them, and they're evenly spaced, and I went ahead and labeled the axes. So I put what the unit, what the value was for each axis, but also the unit. So it's not just volume, but volume in milliliters. Also notice I've got a title. I happen to know if we're looking at the slope of this, so it would be the change in y over the change in x, it's going to be mass divided by volume. I know that that's density. If you weren't sure, you could just say volume versus mass of zinc. That's still a title that describes that graph. So then I went through and I plotted the points here, so you can see the little dots on the graph as I go. And then I noticed that they pretty much make a straight line, but it's not perfect, so I got out a straight edge, so an edge of a paper, or calculator, or ruler, and I tried to draw a straight line that goes through as many points as possible, but obviously I didn't hit all of them, and that's okay. That allows for some outliers in a scientific situation. And I've circled 2 data points here. So I've picked out this graph point up here, which is the last one, and I picked one that is not actually a data point, but that actually hit 2 points on the line here. So here are going to be my 2 points. So if you wanted to write them out, that means, let's see, our first data point we used was this guy right here. And then our second data point would be actually, what is that, 35 grams and about 7.5. So when we put a list of vocabulary, there's 2 I haven't talked about yet, and it's interpolation and extrapolation. So it has to do with predicting or making new data points based on your graph. So if you're interpolating, the prefix inter means within a set of data points. So for example, if I wanted to figure out, if we wanted to find on our graph here, we wanted to know, let's see, what is that, 16.5 milliliters. We could go up here, go up and over. We could figure out how many grams that would be. And since that's within our data points here, that's considered interpolation. It's between them. Extrapolation, prefix extra means outside. That means it would be outside the data points. So let's say, let's see, our volume of zinc ends at 20 milliliters, but what if we wanted to know how much 24 milliliters would weigh? Well, if we went to 24, we had to extend the line here, we could go up and over, we could figure out about what that volume would be, but since it's outside of our known data points, it's considered an extrapolation. So if we look at our graph, well, 1 is outside our data points, right? Our last data point was 2. Oh, wait, nope, it was 3.44 grams. So we come over here, and 1 would be outside our data points. We could figure out what it crossed over, and I'd say, I mean, this is a real big estimate, maybe half a milliliter. That is a big 4 milliliters. Okay, that's within our data points. We could go up and over here. I'd say it's under 20.
So now we have a couple of questions to answer. Number 1, based on your best fit line, what volume would 1 gram of zinc take up? So if we look at 1 gram on our graph, it would be way down here on the y-axis. And in fact, actually, 1 gram is outside of our data if you look over here at the mass of zinc. So we're going to have to see where it crosses that line. So 1 gram, up and over, and I would say that volume would be pretty small, less than 1.5, so maybe we could do 0.75 milliliters. And is this example of interpolate or extrapolate? Well, it's outside of our data. The smallest data we had was 3.44 grams, so it's outside, so it's an extrapolation. The next question. Best on your base fit line, what mass would a volume of 3 milliliters? So we go, find our 3 milliliters, go up and over, see that hit just under 15. So maybe we would say that was about 13 grams. And then we have to decide whether that's an interpolation or extrapolation. So if you go back to your data, 13 grams, well, that falls within our data, right? It would be right in between these two, so it's within. We'd say that that's an interpolation. You can also look at your graph. It is between data points, so it's considered to be an interpolation.